Hello everyone, welcome back to another Watch Me Do Math video. If you're new to the channel, this is Watch Me Do Math. There are new maths and physics videos every Sunday. And so if this helps you, please be sure to subscribe and share with your friends. In this video we're going to be going over only the maths and physics questions from the Section 2 paper of the BMAT from 2018. I'm not going to be doing biology or chemistry because those are not my area of expertise at the moment. So I will be focusing on the mental tricks and the mental steps I go through in order to complete these questions as fast as possible. Let's begin. So, people with cystic fibrosis, okay, biology, chemistry. Okay, here are 4 statements about light. In a vacuum, green light travels faster than blue light. False, because light always travels at the speed of light in a vacuum. In a vacuum, the wavelength of red light is greater than the wavelength of green light. Yes. This is because red light is less energetic than green light. In water, red light travels faster than it travels in a vacuum. Does it have other options? No. I'm not sure about this one actually. In water, the frequency of blue light is greater than the frequency of red light. This is definitely true, because the speed effects on red or blue light differ depending on, as in, the medium through which light waves are traveling will affect the speed of that light in different ways, but the difference of that effect is not enough to change how, the basic fact that blue light has a greater frequency than red light. So I've just remembered what this is. At the moment, I could immediately say 2 and 4. E. Stop looking at the question. Just stop. You found 2 correct answers. You found the correct multiple choice option. Just move on. But for interest's sake, I'll let you know that red light traveling faster than it travels in a vacuum. Okay. I thought this said red light travels faster than blue light, but this is not. I just misread the question. So this is definitely wrong, as water has a higher optical density, as in it's harder for a wave to pass through it, an electromagnetic wave to pass through it, than in a vacuum, so it goes slower. So anyway, the key thing to notice here is that once you have 2 options that are correct, just because it's in this format where it's only looking for 2 correct options at a time, just pick your answer and move on. And this is in order to save time. Okay. Which one of the following is simplification of 48 m5 here? Okay, so this 6 over 5 m5 n2 m cubed p over p squared. 6 over 5m cubed p negative 2 here. So, how did I do that quickly? Well, the first thing to note is that you can cancel different parts with each other one at a time. So, if you think of this not as just that one particular fraction, but also as broken up into 3 parts, like 48 over 40 times m5 over m2 times p over p cubed. Do not waste time writing it out like this, but this is just to show you how the method is valid. So you pick 2 factors that look like that they can be simplified down from one another, such as 48 and 40, and you go, oh yeah, 48 is 8 times 6, 40 is 8 times 5. Or you could simply have this mental fact in your head without needing to think about it. So you'd go 40 over 40, you draw the line, you cancel it, and write what's new on top of it, so 6 over 5. And then m to the power of 5 over m to the power of 2, again, you cancel it, and you know that goes to m cubed. And p over p3, you cancel it, and p to the negative 2 is a bit annoying to write out, so given that this is the last step, you might not need to write it out at all, or you can do what I did and write over p squared, because that's another way of writing the same thing. You draw the same number of lines, but it requires less fine control than doing this, so it's marginally faster. So anyway, once you've done that, you look at the options available, and then you're concentrating on 6 over 5, because that's the cancellation of 48 over 40, so you can ignore these 3. And then it's obvious after looking at the exponents from each that you want this option. And so I reiterate, the fast way of canceling a fraction like this is to put a line through two things that can be cancelled, or you could cross them out individually and write the new thing on top. Okay, nitrogen cycle, this is biology. Fractional isolation is chemistry. A wave traveling through a material has a frequency of 50 Hz and wavelength of 40 meters. How long does it take to travel through 100 meters of this material? Okay, V equals F lambda, our wave equation, so frequency is 50, wavelength is 0.4. 0.4 times 50 is 20, because 0.4 is 2 over 5, right? So 20 meters per second, so 5 seconds. So the first thing you needed to know is that you must instantly recall the wave equation because you are given frequency, wavelength, and you need something to do with speed. So V equals F lambda is the most relevant equation to use in this scenario, and happily V equals F lambda is already in the form that you want because V is a subject. So then for the calculation of 50 and 0.4 meters, one thing to keep in mind is that you should always be able to immediately recognize the fifths. So like 0.0, 0.2, 0.4, 0.6, 0.8, 1.0. If you see a number like this, you want to recognize that it's like 0 over 5, 1 over 5, 2 over 5, etc. because that will usually help you do the mental arithmetic faster. Because 50 times 2 over 5 as opposed to 50 times 0.4, because this is how you might view it in your head, or this is where your instincts might kick in and lead you to. You can cancel these 5s, and then you get 10 times 2. Because like if it's 1/5 of 50, 10 multiplied by 2, 20. So that's one way of thinking quickly about it. And then you should also immediately recognize that 20 meters per second over 100 meters, you should recognize that 20 is 1/5 of 100 again. So going back to this immediate recognition of the fifths, by recognizing that 20 meters per second over 100 meters is 1/5 of the track that is completed per second, you should immediately be able to think that it's 5 seconds. Okay, so moving on to the next question. My wallet contains two 50p coins and 5 20p coins, only 70p to buy an item. If I pick 2 coins at random from my wallet, what's the probability that I pick the exact money to buy the item? Okay, so you already know that you need one 50p and one 20p. Okay, so if you have 2 of one and 5 of the other, basically you're looking for, you could either have one of the 2 first coins or one of the 5 second coins, so 10 valid possibilities over, well, 7 choose 2 total possibilities. And 7 choose 2 is just using the choose formula. It's 7 times 6 times over 2. So you leave this 6, 2, cancel 3, 7, 3, 21. So it's 10 over 21. So the reason that this was fast was because we used the total number of possibilities to find out this probability instead of going through all of the possible drawing out of different coins. So the way that this strategy works is that you find the number of possibilities of the situation that would actually allow you to succeed. So there are 10 possibilities, given that there are 10 unique combinations where you have one of the 2 coins like A and B, and if you have one of the 5 20p coins, 1, 2, 3, 4, 5, as in you could have A1, A2, A3, B1, B2, B3, and so on. So those are your 10 valid possibilities. And then why do I immediately write this down, 7C2? Because 7 choose 2 is a mathematical way of looking at the number of possibilities of something. So say you had like 2 slots to fill with these coins. So there are 7 possible coins that you could choose to fill the first slot, and there are 6 possible coins after you've removed one that you could choose to fill the second slot. And if you picked a coin A and B, just 7 times 6 would count this as being different to coins B and A. So since the order doesn't matter, and there are 2 possible orders of 2 coins, you divide the whole thing by 2, which is 7 choose 2. So this is 2, which is 2 factorial. That's where it originally comes from. But for the purposes of this question, you don't need to think about that. So 7 times 6 over 2 is your total number of possibilities, because you think of one coin slot and then another coin slot and then divided by 2, because the order of the coin slots doesn't matter. You can have the first one at the front or the first one at the back. So then you do the same fraction cancellation thing, and you get 3 on top, and 7 times 3 is just 21. And that's your final probability. Okay, so let's move on. Okay, cells, biology, chemistry. Quantities involved associated with a moving vehicle include its velocity, speed, momentum, and kinetic energy. Which of these quantities will always change if the vehicle changes direction? Okay, velocity will always change, momentum will always change. Speed is a directionless quantity, and kinetic energy is a directionless quantity. It's basically a way of asking you which of these are vector quantities that describe the body's motion. So velocity and momentum only gives us option E. So velocity, the velocity of a body is a vector, and momentum is just the velocity multiplied by the mass. And because these two vectors both describe not only the actual speed, which is the rate of change of its distance rather than displacement. Speed is if I was running in a circle at 5 meters per second, even though after a few seconds my average velocity would be 0, my average speed would be 5 because I've covered this curved distance, right? So anyway, you have this velocity, which describes the direction of the body, but speed does not describe the direction of the body. It's just a scalar number, so it could be like 5 meters per second, but it doesn't tell you in what direction. Momentum is a product of velocity. It's just scaled up by the mass for problem-solving purposes. So again, if you have a body moving in a different direction, its momentum will be pointed in a different direction, and so it's not really the same quantity, is it? And kinetic energy is just a product of speed. So if you have a body that is moving at 5 meters per second, then its kinetic energy will always be half m5 squared, no matter what. Because even though it says half mv squared, that v, I don't think, is actually referring to the velocity of something, and instead it just refers to the speed of that body. So kinetic energy is a scalar quantity that is used for problem-solving purposes, and it doesn't actually tell you anything about the true direction of the body's motion. So knowing this and this are the correct answers, you just look through to find the right option. And moving on, all 4 corners of a rectangle are not the circumference of a circle. Rectangle has a perimeter of 24. Ratio of length to width is 3 to 1. Okay, area of the shaded region. So this is 3, 3, 1, 1, 3, 3, 1, 1. If it's 3, 1, 3, 1, the total thing adding up these ratios is 8. So if the total perimeter is 24, we must scale all of these sides up by 3, so that's 9, 9, 3, 3. And so you want the area of the shaded region, so it's the circle minus the rectangle. 3, 9 through Pythagoras' theorem. Well, actually, we're going to look at this one because it's simpler. So it's root 9 plus 1, so which is root 10. So that means this hypotenuse is 3 root 10. Or rather, the radius of the circle is 3 root 10. So if you have pi 3 root 10 squared, you have pi 9, 10, or 90 pi is your final answer for the size of the circle. and this rectangle, again, 9 times 3, it's 27 centimeters squared, so it would be 90 pi minus 27. So just checking that I have done this correctly. Never mind. This is the whole diagonal would be root 10. So this is 3 over 2 root 10, or 9 over 4 times 10. So 90 over 4 pi minus 27. Let's see if there's anything like that. Well, 90 over 4 cancels to 45 over 2 pi times 27, and it's right here. Alright, so what time-saving tricks were employed in this scenario? Well, the first step to find the actual side lengths of this rectangle is to first just draw it out in ratios so that you know if one part in this ratio was 1 centimeter, it'd be a total of 8 centimeters. And the fact that it's 24 centimeters, you should immediately recognize that that's 8 multiplied by 3. So you just scale up the rectangle by 3 to get the true side lengths. And the second time-saving trick was that we calculated this diameter, or important figure for the circle anyway, the radius, with Pythagoras' theorem on the simpler triangle. Because if we had chosen to do this sort of root 9, which is 81 plus 9, root 90, it would still take us a little bit longer, whereas here you can just go immediately 3, 9, 1, 1, 9 plus 1, 10. So this whole diagonal here is going to be root 10. Or this is half of root 10. So if you scale it up by 3, you just get 3 halves of root 10. So the trick here was to find the hypotenuse in the simple situation first before scaling it up to the harder one. And then again, for the cancellation, I recognize that 90 and 4 are both divisible by 2, so we can cancel them out to get the new fraction 45 over 2. The shaded area should have been immediately recognizable as being this rectangle minus this circle. So I knew that to get the radius of this circle, I just wanted half of this hypotenuse here of the whole, or half this diagonal of the whole rectangle. So the reason we did not find our answer in the beginning was that it was not in a fully simplified form. It also gave me the tip off that I had done something wrong when this 90 pi or minus 27 did not show up on the list of possible answers. So that's how I knew to check my working and make sure that it was all valid. Alright, so moving on. Biology. Chemistry. Okay. A champion weightlifter raises a 200 kilogram set of weights from the floor to above his head in one movement. The bar is lifted through a vertical distance of 1.8 meters. When the lift is completed, the weightlifter holds the weight stationary for 2 seconds and drops them to the floor. At what speed do the weights hit the floor? Okay, well, the cool thing is that mass doesn't matter. None of the information in this question is relevant except for the distance of 1.8 meters. And that's what my physics intuition is telling me, because all things in a uniform gravitational field will fall at the same speed. So given that this field strength is 10 newtons per kilogram, this is equivalent to a free fall acceleration of 10 meters per second, or g is 10 meters per second. From the equation W is equal to mg, this is what this is saying, basically. So g is 10 meters per second. Using the SUVAT equation, S is equal to ut plus half at squared, knowing that u is 0 because it's dropping from a position where he was holding it stationary, we cancel out this term, and so s is equal to half at squared. Or 2s is equal to at squared, 2s over a is t squared. Or wait, hold on. We want v. Okay, so v squared is u squared plus 2as. We're using this SUVAT equation. It's 0 plus 2, 10, 1.8, 2, 10, 1.8, 20, 1.8, 3.6, 36. So v squared is 36. V is 6 meters per second. Okay, so I did a bit of a stupid thing here, and I thought I was calculating time rather than speed, even though I had read the question correctly. So I realized that the most relevant equation here from the SUVAT arsenal is v squared is equal to u squared plus 2as. If you're not familiar with the SUVAT equations, I strongly recommend getting familiarized to them because they are incredibly useful for problem solving like this. So with this equation, u squared is immediately destroyed, cancelled to 0. You don't need to write this arrow, but you can just cross it out and imagine that it's gone. V squared is equal to 2as because it started at a velocity of 0. So a is that acceleration that the weights experience, which is 10, as we already know, and s is 1.8 meters. So what happens here? Well, you could have gone like I did in 1.8, even though I think that was a bit of a blunder, because a real fast way to deal with this is first realizing that you can use this factor of 10 here to remove the decimal place from this 1.8 to speed up your calculation. So if v squared is 2 times 18, this would help you more immediately recognize that you want v squared being equal to 36. And 36 you would then immediately recognize as being 6 squared. And so v becomes 6, naturally. So now let's move on to this question. The first 4 triangular numbers are 1, 3, 6, 10. The difference between the first and second is 2, second and third is 3, fourth is 4. All the triangular numbers follow this pattern. The difference between the rth triangular number and the r plus 3th triangular number is 1, 2, 6. What's the value of r? Okay, so if this is the first triangular number, the second triangular number, the third triangular number, then you want some difference between second and third. So it's the bigger one is equal to r. So you want some thing where if you have a r plus 1, r plus 2, r plus 3, the difference between them is going to be r plus 1, and then r plus 2, and then r plus 3. So if the total difference is 126, then 3r plus 6, which is this plus this plus this, is going to be equal to 126 minus 6 from both sides. 3r is 120, r is 40 divided both sides by 3. So the value of r is 40. So how did we go about this? This kind of question is quite interesting because you need to use what you know about sequences in series. So the thing that was useful to me was that you could basically find any given triangle R or triangle. Well, anyway, this symbol doesn't make much symbolic sense here, but if you have some triangle number Tn, then that's n plus the previous one. And while this is just a mathematically formal way of saying that if you have r plus 1, then this is going to be r plus 1. If you have r plus 2, this is going to be r plus 2. If this is r plus 3, this is going to be r plus 3. To go faster, you need to make sure that you don't try and write out any of this mathematical formalism, but just the most important parts of solving the problem, which is that if you have these this triangle r and triangle r plus 3, then what are the triangles between them? Well, it's r plus 1 and r plus 2. And then what are the differences between them? And you already know the difference from the fact that if you have triangles 1, 2, 3, and 4, it takes a difference of n to get to triangle n. So 2, then 3, then 4, and so on. And intuitively, this rule is quite easy to extend to the case of r all the way to r plus 3. You just need to make sure that you're not wasting any time writing out the mathematical, formal way of describing this, because once you have this equation, then it's pretty trivial to get to the final answer with some speed. Okay, so moving down, this is biology. This is chemistry. A circuit consists of a 10-volt resistor and a variable resistor connected in series with a 6-volt battery. The variable resistor have a minimum resistance of 2 and a maximum resistance of 20. So what is the difference between the largest and smallest currents possible in this circuit? Well, resistors in series add up, so it's more like 12 to 30, and if it's 6 volts, then voltage over resistance is equal to current, so 6 over 12 is 1/2, 6 over 30 is 1/5, half is 0.5, 1/5 is 0.2, and 0.5 minus 0.2 is 0.3 amps. So the first thing to do here would be to sketch the circuit diagram. You don't even have to do it properly. You could just write it out. So it's like 10 and 2 to 20 with a 6-volt battery. And the key here is that you see this emboldened word difference, and you know that you need to calculate two things, and also the idea of I is equal to V over R that you need to remember. Because like the idea of potential or potential difference is not something that you can teach yourself during an exam like this, but if you don't fully understand it, you may want to look at other resources on the topic, or you may just want to make sure that you remember and memorize this formula for use in this question. Resistors in series add up because they're like different obstacles on a course, right? So if you were running along and you saw one bump and then another bump, the total difficulty of that course would be the two bumps, right? But if you saw one bump or there was another course that had another bump, that doesn't necessarily mean they add up. So this is how you can intuitively remember that resistors in series add up to make a total resistance of that loop, but resistors in parallel do not. And so knowing that, you take this 10 and add it to 220 to get the final answer for the resistance of 12,230. And then knowing this, again, you do the calculation using this I is V over R idea. The way you can think about it is that voltage is a way of dropping things down, or like if you stood up on a hill, then your gravitational potential difference, which is the gravitational field version of voltage, would be quite high. So if you dropped a thing through something with a lot of resistance, so if you had a ball and you dropped it through air, then it would fall quite fast, right? Your current will be higher because the resistance is lower. But if you had a ball and you dropped it through some thick honey, then the ball would fall very slowly, right? And that's because the resistance of the honey is more. So your gravitational potential energy is converted to kinetic energy less effectively when there's more resistance, right? And that's the same idea here. There's less current, there's less kinetic energy of the electrons if there is more resistance. So that's how you would remember it. You could remember the VIR formula pyramid thing, but this is not necessary when you just have the intuition that voltage is like standing on top of a hill and resistance is like anything that stops you from going back down. Next thing here, the mean mass of a sweet in a bag of 20 sweets must be greater than 10 grams, but not greater than 10.5. A bag is being filled with sweets. The mean mass of the first 16 is exactly 9.5. For 4 more sweets, each of mass x, are added to the bag to bring the mean mass into the correct range. Okay, so if you have 16 sweets, exactly 9.5 grams, 16 times 9.5, we'll take the 0.5 out, so it's 17 over 2. 16 and 2 cancel out, 8 times 17. What's 8 times 17? 8 times 7, 56, and then 80, so 136. In total, there are 136 grams already, plus 4x grams for the sweets, divided by 20 sweets, must be between 10 and 10.5. So this is just us quickly working out an expression for what would the actual total mean of the entire bag be. And this 10 and 10.5 allows us to keep this within the range that's described in the question. So multiply both sides by 20, you get 200 is less than 136g, and then 136 plus 4x is less than, well, 10.5 times 20 is 210. And so subtracting 136 from both sides, you get well, this is a 19. 8 times 19. So this should be 72, and this 136 should be 152. Because my intuition told me that this was a little bit off. So 200 less than 152 is 4x, 210. 152 to 200 is 48. So you know that 200 goes to 48, and then plus 10 is 58 on this side. So if 48 is less than 4x is less than 58, divide everything by 4 and you get 12 is less than x is less than. Well, 58 is a little bit less than 60, so and 60 goes to 15, so 58 goes to 14.5. 12 must be greater, but not greater. So it's A because must be greater implies strictly greater than, but not greater implies less than or equal to, because equal to is not greater, right? So these are the correct symbols that we want, and the answer would be A. So I suppose the only tip here is to make sure that you can read the question as fast as possible and get it into this inequality as fast as possible, because this is a question which is a bit hard to think through in your head, and really the mathematical formalism of the whole thing is the best way that you have to deal with this problem. Okay, animal cell biology, chemistry. Okay, radioactive isotope plutonium-244 becomes radon-220 after succession decays. Atomic number is 94. Atomic number is 86. How many alpha and how many beta are emitted altogether? Okay, so if you have 244 to 20, 220 and 94 to 86, there's a minus 24 and minus 8. So, oh, what happened to my pen? Okay, so there's minus 8 here. Usually, because there's this mass decrease of 24 atomic mass units, half of that was going to be neutrons and half that was going to be protons. So if one alpha particle is 2 of these, that means 6 alpha decays must have happened. So how come there's only 8 proton losses? Well, we know that 6 alpha particles must have been emitted. There are 8 proton losses because a beta decay exchanges a neutron for a proton, basically. The original result, which would have been like 220, the 94 minus 12 is 82, has too many neutrons, and so some of these neutrons decay into protons. And so if there are 8 fewer protons, that means instead of minus 12, then that means there must have been 4 extra protons created somewhere, which gives us 4 beta decays. So the basic thing to memorize here, or to keep in mind, is that 1 alpha decay is 4 mass losses. An alpha decay is the only way total mass can be lost. So you look at the alpha decays first. And the next thing to do is the beta decays, because the beta decay is the only way that proton number can be lost without losing mass. Or it's the only way that proton number can be gained. So we know there are 6 alpha decays because of looking at just the mass, and even though the proton number should have been 82, but it is actually 86, we know that 4 protons were created out of other particles, and that means there are 4 beta decays. So in summary, alpha is losing mass, and beta is gaining protons. Another way you can think of it is that in terms of the top number and the bottom number, where alpha decreases the top number and you work that out first, and beta increases the bottom number. Beta increases the bottom number, and you work that out second after you've worked out the effects of that alpha decay. Okay, right, next question. Which one of the following is a simplification of this? Oh god, this is disgusting. X squared plus 2x minus 3, I'm thinking we maybe you're going to be able to factorize it. X squared plus 2x minus 3. well, you have two factors, multiply to minus 3, add up to 2, so it's minus 3 and positive 1 probably. So x minus 3, x plus 1. Oh god, this is not nice. No, x plus 3, x minus 1, because you multiply them together, you get that plus 3, x minus 1x, right? Okay, so x over x minus 1 minus x squared plus 3 over x plus 3, x minus 1. To get this in the like terms, you multiply both sides by x plus 3, so it's x plus 3, x minus 1. Well, this whole denominator is the same, x squared plus 3. So it's x plus 3 minus x squared plus 3. So if this is x squared plus 3x, and this is x squared plus 3, we cancel out the x squared, and you just have 3x minus 3. So 3x minus 3 over x minus 1, x plus 3. Well, this is equal to 3 times x minus 1, so this and this cancel out, and you get 3 over x plus 3, which is answer B. Okay, so let's break down the mathematical tricks we had to go through first. Because there is no simple way to simplify this thing, I knew we had to complicate this thing. And the way we did that is first by factorizing the denominator, which is a quadratic equation. So why did we do that? Well, that's because I wanted to figure out what the factors were so that we could put this in like terms. Because if this x minus 1 happened to be a factor of this denominator, which it was, then we'd have an easy way to put this top fraction in like terms by just multiplying by the other factor, x plus 3, divided by itself, which is equal to 1. In the same way how you might multiply by something over something which is equal to 1 when you're perhaps rationalizing the denominator of some fraction involving surds. So once you have this in the like denominator form, you do the subtraction, which is x times x plus 3 minus x squared plus 3. And you'd get this. The thing is, you don't necessarily need to write the brackets, or you don't need to keep your working tidy, basically, because it is a multiple choice paper. So the only essential things that you need to write out are the new fraction here. So you'd be like, oh yeah, okay, so this goes to this, and then you'd write out, oh, it's x squared plus 3 over da 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 da, because you know the denominator is equal to this thing. You don't need to write it out again. So it would be, you'd write something like, oh, it's x squared plus 3x or minus x squared plus 3. Or you don't even need to write that out because you're only looking at the top thing. You no longer need to write the denominator. And after you have gotten something like this, then you can just cancel the x squared on both sides because it's x squared minus x squared is 0, and you're left with 3x minus 3. And finally, what else? Well, if you have 3x minus 3 over x minus 1, x plus 3, you may have spotted that this is got a factor of x minus 1 in it, and if you can see immediately that this is just cancels to 3 if you cancel this out, you can just do that. You can just strike it through and write 3. Because if it's something that's obvious to you, then there's no point in spending extra time to write it down. You just write 3 over x plus 3. Okay, so this is biology, genetics, this is chemistry. And finally, a physics question. The radioactive isotope carbon-14 is found in every living material, small quantities. There are 1,000 carbon-14 for every 10 to the 15 carbon-12. When the material dies, the carbon-14 decays and is not replaced. Half-life of carbon-14 is about 6,000 years. In a bone, the ratio of carbon-14 to carbon-12 is 100 times 2, 10 to the 15. Okay, closest estimate of the age of the bone. Well, anyway, we know that it's gone down by 10 because it used to be 1,000 10 to the 15 versus 100 10 to the 15. So basically, gone down by 10. And one way you can think about this is what decreases something by 10 times? Well, we know what decreases something by 8 times, and that's 3 half-lives. We know what decreases something by 16 times, that's 4 half-lives. So we want something that's like in the middle. So it's just a little bit more than 3 half-lives. So what's a little bit more than 3 times 6,000? Well, this is going to be a little bit more than 18,000 or 20,000. So the key here is to be be comfortable with the estimations that you do, because there is no easy arithmetical way to calculate a decimal log, and there is no need to either, because these answers are spaced so far apart. If you have this reduction in the quantity of carbon-14 of 10 times, it's a radioactive isotope. You know that happens after so many half-lives, and you can work out the number of half-lives from the fact that 10 is just a little bit more than 2 to the power of 3. So that's why it's like a closest estimate, right? And then if you have this slightly more than or slightly less than idea in any question that you're doing whatsoever, then you can keep that slightly more than or slightly less than as an estimation tool as you work through your calculations, like I did here. So like my slightly more than 3 times 6,000 became slightly more than the answer to that, or slightly more than 18,000, and that led me to the correct answer. So that's all I have to say about this paper. Hopefully watching this video helped you prepare for your own BMATs coming up soon. And if this helped you, do subscribe and share with your friends. Thank you for watching.